Alright, so I've set up some examples here and I would like you to be able to work them through with me just so you can get a feel for how to use the discriminant and what it's useful for, what its uses are. So I've gone ahead and written up what the discriminant is up here so we can start applying it in these a couple of examples. And feel free to pause this video whenever you need to. You can go back and watch it however many times you need to. And I'll just give you some suggested times to pause and to work on it by yourself. Alright, so starting off with number 1, let's go ahead and identify what our constants are. So A is equal to 3, B is equal to -2, because this is negative right here. It's a negative, or 3x squared plus -2 is how you could think of it, or 3x squared minus 2. C is equal to, again, it's another negative number, it's -5. Alright, so to plug this into our discriminant equation, we have b squared, which is so -2 squared, minus 4 times a, which is 3, times c, which is -5. So simplifying this, we get 4 minus, or actually plus, because you can see that these negatives right here are going to cancel each other out. So that makes things a little bit nicer. So now we've got 4 plus 3 times 4, which is 12, times 5, which is equal to 4 plus 60, which is equal to 64. So, because this is a positive number, we know that this equation, this particular equation here, is going to have real solutions. So if the question is asking, does this equation have real or imaginary solutions, you can just go ahead and finish there and say real. A lot of the homework questions are going to actually ask, though, for the solutions if they exist. So if the solutions exist, then they want you to go ahead and finish out the quadratic equation formula and find the equations for this. And some questions are going to ask you to graph them as well. So I'll just help you out with that. If you want to take a moment now, you can pause the recording and see if you can figure out what the solutions to this would be on your own. Alright, so I hope you have been able to work that out for yourself and maybe have come up with some stuff that should be review and some good practice as well. So let's see, our quadratic equation, we would just put this equation under the radical and have minus b, so let's see, minus b plus or minus, I'm just going to put d here for the discriminant, over 2a. So we know that b is equal to -2, so if we take negative b, that would be negative. Here, let's switch colors. So -2 plus or minus the square root of d, which is the discriminant, which is this number up here, right? This is our discriminant. So that's over 2a. So that's going to be equal, well, 2a, a is equal to 3. We know what that is, so we can just go ahead and plug that in. So then this becomes, once we simplify it, 2 plus or minus the square root of 64 over 6, which is equal to 2 plus or minus 8 over 6. And then those solutions then become, let's see, those would be -1 and positive 3/4, -1 and +5/3. So those are going to be the two solutions then for this particular equation. So if the question asks you to go ahead and graph it, this is handy because you know then the two places where it crosses the x-axis. So that's going to be at -1, so if we just go ahead and put a dot there, and then at +5/3, so that's going to be like 1 2/3, so somewhere about there-ish on this graph. So we know that it is going to be an upward-facing parabola because this constant right here is positive, so it's upward facing. And we don't exactly know where the vertex of it is, but we can make a rough estimate of what the graph is going to look like regardless. So something along those lines. And if the question is asking for just a rough sketch, then this will do just fine. If on the other hand the question asks for something a little bit more detailed, you can use some techniques that we've already covered to graph this in greater detail. Alright, so moving on to the next question, let's go on to number 2. Alright, so this time we are given the equation -8x² plus 6x minus 4 is equal to 0. Okay, so this time let's see if you can figure out if the discriminant is positive or negative on your own this time. And just take a couple minutes to work on that by yourself. Alright, so coming back from that, let's see if you were able to get the right answer. So we know that the discriminant is b². So this is I'm just going to write it right beneath it. I'm not actually going to write them out. b², which is 6. So that's 6² minus 4 times a, which is -8, times c, which is -4. Okay, so we've got a couple of different negatives going on here. So let's go ahead and just like point these all out and just like hopefully we can sort them out and not get confused by them. So we've got 3 negatives, so so when you multiply these 3 numbers together, this one, and this one, we're going to still get a negative number for, you could essentially say what's in this parentheses. So then we would get 6², which is 36. 36 plus, or minus actually, let's just keep this negative out here. 4 times 4, which is 16 times 8, which is 128. Alright, so then that works out to be 36 minus 128, which is equal to -92. And then, of course, you can like use your calculators to do the arithmetic for this so that you can focus on more of the concepts and not just get bogged down with the arithmetic. So now we know that this right here is our discriminant and it is negative, which means the solutions are not real. So again, if that's what the question's asking for, if it's real or not, that's all you can put down. Boom. You see that it's negative, you don't have to go on. In fact, at this step right here, when I when I saw how many negatives there were, I could almost stop there. I could stop at this step right here because I could see that 36 is smaller than 128. And I could see that this would be a negative number, negative. So if that's what the question's asking for, that's all you have to do. Of course, you can go on and figure out what the solutions are going to be, but they're going to be imaginary solutions, so not terribly relevant. So for this question, we can just stop right there. And again, if you graphed it, it would look something like a downward facing, well, it's a downward facing parabola. So something like that, or perhaps like that. And you could, again, go through the trouble of graphing it. Sometimes it's good to have a visual like that to help you out. But I find that using the discriminant is a much easier way to see if the equation is real or if it doesn't exist on the graphs, because graphing can just be a little bit, take a little bit of time as opposed to just plugging some numbers into the discriminant formula. All right, so moving on to question 3. This is the last one. So let's try this one. Just you can try this one by yourself right now, and then we'll work through it together once you come back. All right. Okay, so this one is a little bit more complicated. I'm sure you noticed, because I didn't give it to you in a nice, like, clear way. I actually gave it to you in the form that isn't quite in the quadratic formula way. So let's go ahead and clean this up real quick. We've got negative 2x squared plus 10x minus 9/2 is equal to 0. So you can do that by moving this over there, and you get negative 5 minus 1/2, which you can make turn this into a fraction. Whoops. Negative 10/2 is equal to negative 5. You just switch it up like this, minus 1/2, and then you get negative 9/2. So there's how I got that. And just clear that out of the way. So that's our new equation that we're going to work with. This is A, this is B, and this is C. So B squared is 100. 4 times A, which is negative 2, times C, which is negative 9/2. So let's just go ahead and cancel these terms right there. And we'll get negative 4 times negative 1 times negative 9. Again, these terms will cancel, and we'll be left with 100 minus 4 times 9, which is 36, which is equal to 64. So, hallelujah, we've got a positive discriminant. This is great. So this is our discriminant. We are able to find real solutions to this problem now. And let's just go ahead and figure those out. Since we know A, B, and C, we can plug this into the quadratic formula. We've got 10. Oh, and if you want to take a minute right now, then to do that on your own, you can just go ahead and pause the recording. So for B, we've got negative 10 plus or minus the square root of D over 2 times negative 2, which is equal to negative 10 plus or minus the square root of 64 all over negative 4, which is equal to 5 plus or minus 8 over 2. So then the solutions for this are going to be, negative 3/2 and 13/2.